So let's start. So today's topic is set theory. What is set? Do you know the definition of set? What is the definition of set? Definition of set is unordered collection of objects. Each of these word is very important. First one is unordered, second one is collection, third one is object. Now tell me, what is object? What is object? Do you have any idea?
So anything that is tangible, like we can,
How about untangible things like numbers?
yeah, they
I'm
are
not
objects,
there.
like elements. All the elements are,
All the elements in object. Whatever you
yeah,
can imagine, whatever you can think, those are object. Am I right?
yeah, yes, sir.
So subject like be like this. One, A, Bijoy, then what? Orange, human figure. Those things. Anything can be considered as object. Am I right? Okay. So unordered. What is the meaning of unordered?
They can be set in uh,
Any arrangement.
sequence, in any
So
sequence.
any sequence. So arrangement is not important. Am I right? Unordered means arrangement is not important. Collection. What is the meaning of collection?
A group of set kept in a group.
Yes, yes. But collection do have a special quality. What is that one?
Lot of them,
Collection.
lot of them are present together.
No. Collection means duplicate is not important
Count. Right.
if duplicacy happen. We can discard. Okay. So these are the three important points in the definition of set. First important point is object. So object is what? Object is anything which can be imagined. Second thing is unordered. Unordered. So unordered means arrangement is not important. Third thing is collection. Duplicate is not important. If duplicacy happens, we can discard. So let's take a set. So before taking any set, we always consider a mother of all sets. Did you understand? Did you understand or not?
Universal set.
Yes. We consider mother of
The universal set, isn't it, sir?
Mother of all set. Where?
The universal set.
Wait. Before creating any set, we consider mother of all set where all the numbers we are dealing with should be present.
All the numbers are objects.
Yes, objects, numbers, let's call it objects. And it is called universal set denoted by capital E. Alright? Now let's talk this out. Let's assume my universal set is an universal set is also a set. It's also a set. Okay? Now, if I write A equal to 1, 2, 3, A dash equal to 2, 3, 1. Is A equal to A dash?
Yes,
Yes,
Why?
because they are
because
just rearranged in another sequence or
and
arrangement, but they are
uh,
members and the elements of the sets are identical.
like
Anything else?
order
Order
is
is
not
not important. Order
Yeah.
is not important. So because of that one, they are equal. How about this one? Is A equal to A double dash?
Yeah,
yes,
Why?
because duplicate is
because
not important.
duplicity is not important.
Duplicate is not important. If there is a duplicate element, we can discard that one. So this one also becomes equal. So A equal to A dash equal to A double dash.
So I have a question.
Yes, please.
So we are cancelling the duplicate element in our head, or for the writing even we'll be not writing it anymore. Like,
Yeah, so that is the thing actually. So that thing is actually whenever in computer science you are dealing with data structure, set like data structure, whenever you give duplicate data, you don't consider that data anymore. That uh, one, one exist, existence of one object is more than enough to have the set. If you give any more instance, then it is going to discard that one. It is true. But the thing is, we can discard. We can discard the duplicate elements. Somehow in the set, if there are duplicate elements, we consider those are not there. So we can discard. Okay? So that's the same thing. Not a big deal.
yes, sir.
Usually we don't usually you are right. Usually we don't write duplicate values. True. True. Okay. Done?
Yes, sir.
Yes, sir.
Should we continue to next topic?
Yes, sir.
Yes, sir.
Please mute yourself. Mute, mute. Now let's talk about this. Belongs to represented by this epsilon symbol in set membership. Let's assume my universal set is my A is so let's take one element in the A. We write this one is inside the set A. So we write one belongs to All right, guys. So it is denoting the membership. Is that clear to you guys? Mhm.
Yes, sir.
Yes, sir.
Now, if you take 7, right? 7 not belongs to it. Not a member. Okay.
Yes, sir.
Now let's have an exercise. Now tell me, 1 belongs to E. Is it true or not?
Yes, sir.
Yes.
It's true. 1, 2, 3, 4 belongs to you or not? Belongs to.
Yes, sir.
Yes, sir. Why?
Yes, sir.
Because the whole thing is an element, and it
Whole
is.
thing is done. So yes, that is the good point. So remember, the elements, the objects inside a set cannot be simple. They can itself be set. Okay.
It's like the subset, sir, isn't it?
Subset is different concept. Subset is not like that. It is not
Okay.
called subset. It is a different concept.
So,
So
sir,
we are
is
talking
that
about. Let me finish. We are talking about this object. This
yes, sir.
object can be anything. The elements inside a set or objects inside the set, they can be anything. They can be even set. They can even itself a set. Did you get it?
Yes, sir.
That time it would become set of set. That the object inside a set can be set of set of set. So this way you can go much deeper. Okay. In this case,
Yes,
what happened? In this case, what happened? This set U contains simple element 1, 2, then element as of set of 3, then 4, then set of 1, 2, 3, 4. Did you get it?
yes, sir.
Okay, so remember. So this is true as well. Now let's come to concept of subset.
Sir, one question.
Yes.
Will 3 be an element of universal set?
What
No,
is
right?
happened? Mhm.
Will 3 be an element of universal set?
No, no. Three not belongs to you.
Yes, sir.
But set of 3 belongs to you.
Yes.
Okay.
Thank you, sir.
These two are very
Set of
different, isn't it?
what happened?
But now I get it, sir. This
Yes,
that
3 does.
3 and 3 is
Yes.
very different.
But
So good,
set
sir.
of 3 belongs to you. Yes. Now let's talk about subset. When all the elements in set 1 belongs to set 2, we say set 1 is subset or equal to set 2. Okay? When set 2 has at least one extra element, when set 2 has at least one extra element,
So
we
set one
call
is
we call set
set
1
one
is
subset of set
no,
two.
set 1 is proper subset.
Uh,
Proper subset of set 2 we denote it by set 1, we discard this equal sign. Set 2. Okay? Set 1 is a subset of set 2. Proper subset of set 2. Okay, guys?
Okay,
yes,
sir.
sir.
So I was confused with this proper thing. Like we never had this proper thing before. Like
We do have, I don't get you. What happened?
so, like we always used to say that like subset of set two, set one is subset of set one. Like
Yes,
there's
sir.
something proper, like something called proper
Proper
subset.
set. Then learn today. There is a concept
Yes, sir,
called
yes,
proper subset. Okay.
yes.
The thing is, which one you are using? Which symbol you people are using? The
No,
first
sir.
one or second one?
We have been using both the symbols, but the second one we knew it as subset only, and the first one we knew as equal or subset.
But that is wrong. The first one is called subset. Second one is called proper subset.
Okay.
Okay, so that is wrong.
So what is the difference between both of them?
We are talking about, don't worry. So logically, the logical expression, how can you define set? Subset. How can you define subset? Let's assume A is a subset of B. How can you define?
All elements of A belong
Using quantifiers, yes. For all x, then
all
x belongs to A is a implies to x also belongs to B. Am I right?
yes, sir.
So that is the definition of subset. Am I right?
Yes.
Okay. And what is the definition of proper subset? What is the definition of proper subset? All x belongs to A implies x belongs to B,
Sir, it's not belongs to reclamation.
B, and all x belongs to A implies x belongs to B, and there is some x not belongs to A and x belongs to B. So this is the definition of proper subset. Okay, it's called
Yes, sir.
side subset.
But sir, like just the subset. It can also be like all proper subsets are subsets, but
Right. You are absolutely right. According to this definition, according to this definition, what? How can you relate this to?
like all proper subsets are subsets, but not all subsets are proper subsets.
Mm, but let's think it again.
Sir, will it not be the other way around? All subsets are in proper subsets, but all proper subsets are not subsets.
Yes, so that's why I'm asking you. How can you relate these two?
No, all subsets are not proper subsets.
Yes, so the relation
Yes,
will be
yes,
like this: A subset B implies. Did you get it? This one is the relation
Right, sir.
because
yes, sir.
when it is broken out, whenever this one is one, this one is zero. This one means this one means one means this one is true and this one is true. So if this one is true, definitely this part is true. The both becomes one. So that's it is true. But other way around is not true. Okay? Because
Yes,
other way around, it might happen. It might happen. It might happen. This one is true. This one is false. So whole right hand side is false, but left hand side would become true because this one is true. So this one is the case. Okay? Do you agree with me or not?
yes, sir.
Right.
Because both to become this one true, the both of this should be true. This part should be true, this part should be true. Now if the first part is true, then definitely this one is true, then this one would be true. Am I right? So these whole things become tautology.
Sir,
Wait, on the other hand, if you put it on the right side, this one on the left side, then if you make this one false, then this one, uh, then you can make this one false and this one true, right?
I sir didn't get it.
What is the question? Tell me what happened.
Uh, the second question, where when you change B and A, like interchange B and A, sorry, interchange the right hand side and left hand side. And sir, another thing, that is like when we say A is a subset of B, we are saying all x where x is an element of A implies x is also an element of B. X is an element of B, right? But it could also be that some of the elements of A are not elements of B because it's a subset, or like the subset means it is uh, a, su- a proper subset or equal subset. So this the condition you gave is for equal subset, right? Like equal set. It is denoting A and B are equal, their elements are equal. But
So
what happened?
you want to write another way around, another way around. You want to write another way around. You want
Mm,
to change this to that and that to this. That is your conclusion.
no, sir. That's not
Then,
my conclusion. That can't be done because B is the bigger set
so
here.
what is your conclusion? Tell me what
Uh,
is your conclusion?
uh, I I can't draw the conclusion. That's the problem. My problem is if A is a subset of B, A can either be equal to B or it is just a proper subset,
No, no,
right?
no. You tell the different things. You're telling the different things. If it is a subset, it can be equal or it is a proper subset.
Yes, sir.
That is the definition of subset.
That's what I'm telling.
Okay, and this one means it is only subset. Am I right?
Yes, sir.
Yes. Now, what is the conclusion? Tell me.
Now, if the proper subset is defined by this, all x is an element of A implies B, and the whole thing. Why is why is not why is the subset not defined like that?
I don't get your question actually. What is the question of you? What are you asking for?
I'm asking that, man, we are basically proving the equal set theory here. Like
Now we were
A,
not proving equal set theory here. Yet we did not come to equal set theory. We are talking about subset definition here. We did not go to that topic yet.
Sir, for example, if A is 1, 2, 3, right?
Mm-hmm. Mm-hmm.
And B is 1, 2, 3, 4, 5.
Okay.
We can call A is a subset of B, right?
Of course, of course.
Yes. Uh,
Then,
and if we say uh, A is one, 1, 2, 3, 4, B is 1, 2, 3, B is also 1, 2, 3, 4. We can
mhm.
also tell that A is a subset of B, right?
Right, right, very right. Yes, because they are
But
equal.
for the first condition,
Mm.
which uh, which symbol are we going to use, and how do we understand which one to use? Because the first condition, the first thing, 1, 2, 3, and 1, 2, 3, 4, 5,
Mm.
that fulfills both the conditions. A
Mm.
is a subset, A is a proper subset.
Mhm.
What are we going to do then? Like,
Okay, so I got the question. So let me clarify. Let me fix this problem first. So A subset of B implies A subset or equal to B. Is it true or not?
true.
It is true. So if A is a subset of B, definitely it is a subset or equal to B. Okay. So how about this? If I write this, A subset or equal to B, does it implies A subset or equal to B? Is it true? Definitely not. Am I right? Definitely not. Because if A equal to B, this one become true. This one becomes false. So
False.
whole thing become false.
স্যার
Am
একটু
I right?
একটু উপরে নেবেন তাহলে দেখতে পারবো।
Right. So if I write other way around, if A subset or equal to B, then definitely we can write this because it becomes a tautology. But if I write other way around, A is a proper subset of A is a subset of B implies A is a proper subset of B. We cannot write this way because if A equal to B, then this one become true, this one become false, then whole thing becomes contradiction. Am I right? So we cannot write this way. First of all. Our second thing, let's come to his point. His point is very important point actually. So he says if A is actually 1, 2, 3 and B is actually 1, 2, 3, 4. Okay? A is 1, 2, 3 and B is 1, 2, 3, 4. Which one we are going to use? Definitely, according to this definition of subset, all the elements in A are also present in the B. So definitely A is a subset of B. Am I right? Am I right or not?
Yes, sir.
Now he says, sir, somehow, if A has also the element of 4, still A is a subset equal to B. Am I right?
Yes, sir.
So when you are going to write A is a proper subset of B, it is his question. Am I right?
Exactly.
Okay. So the thing is somehow, somehow, if you are if you are sure one more element in B, then we write a subset of B, proper subset of B. Is it clear to you? Somehow, 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 if we are getting sure that there is a one more element in B, then we write A is a proper subset of B. Is it clear to you guys? Somehow. And now the question is, how can you know? Usually we cannot know that one, that B has one more element. That's why we usually use this symbol, the subset symbol. Is it clear to you guys?
Yes, sir.
So always we keep open the chance that these two sets might be equal. That's why we always write the subset notation. Whenever we are getting very sure that there is one more element in B, somehow, then we write the proper subset. Is it clear?
Yes, sir.
Did am I satisfied here?
Hmm, one more question, sir.
Yes,
Sir,
sir.
if the answer is like A is a proper subset of B,
Mhm.
and someone writes A is a subset of B,
Mhm.
will the answer be correct? Like,
In this case, if A equal to 1 to 3 4 and B equal to 1 to 3 4, both are correct. Am I right? As they are equal, that's why it is a subset of B. Sorry,
eh,
forget about this 4.
yes, sir.
Forget about this 4. So in this case, A is a subset of B. So definitely it is a subset of equal to B. This one is correct. And if you take this one, B has one more element. So definitely it's the proper subset. Both are correct. Am I right?
ইয়েস স্যার, এটাই জিজ্ঞেস করছিলাম যে লাইক মানে অ্যান্সার তো দুইটাই কারেক্ট হবে ওইখানে
Both
তো।
are correct. Both are correct. But if you write 1, 2, 3, 4 here, this one is correct, this one is not correct.
নট।
Because it is not proper subset.
ইয়েস স্যার, থ্যাংক ইউ।
Okay, sir.
So there's another
Good,
question.
good. Yes, please.
So we are saying one more element in B, isn't it, sir?
Yes, sir. One more. At least.
What if?
At least.
Acha, acha, okay,
At least.
okay, sir.
At least. Is that done?
Yes, sir.
I in the original definition here I write at least. Okay.
Yes, sir.
So let's do some more things. Let's try to prove this. Prove that if A is a subset or equal to B, or B is a subset of A, then A equal to B. So how can I prove that one?
So we have to show that both the elements are same.
Okay.
Both of them are the same elements.
Okay. So how can we show that one? We know that A is a subset of B and B is a subset of A, which is logical equivalent to all x belongs to A implies x belongs to B, and this one implies all x belongs to B implies x belongs to A. Am I right? Now,
Yes,
same
sir.
quantifier. If we take same quantifier outside, x belongs to A implies x belongs to B, and x belongs to B implies
এক্স বিলংস টু এ,
x belongs to A. Now, what is this?
বাই ডিরেকশনাল।
Bidirectional, and it's a tautology. This one become a tautology. It is nothing but x belongs to A equivalent to x belongs to B. So, if this one is true, x belongs to A, this one is true, this one must be true. That means whatever element in A, they must be in B. Now, whatever element does not belongs to A, they must not belongs to B
B.
for all elements. So it becomes A equal to B. Did you get the proof? Did you buy the proof?
ইয়েস
Yes,
স্যার।
sir.
All right. Now let's go to talk about another concept that is called empty set. Empty set can be denoted by this empty set symbol or phi. Both are standard notation. So what is empty set?
A set that has no elements in it.
A set which has no elements.
Now, sir, bolo, sir, এটাকে।
Null set, right? Empty set or
Yeah,
null
no.
set. A set which has no elements. A set which has no elements. Okay. Now, Before going to further, let's call another concept called cardinality. Do you know what is cardinality? Cardinality means number of elements in a set. It's called cardinality. Number of elements in a set is called cardinality, represented by this bar on the both sides. Now, let's do some example. My universal set is 1, 2, 3. Now, what is the cardinality of U?
3.
3. Now, what is the cardinality of 5?
0.
0. Now, it is the most important question. What is the cardinality of set of 5?
0, sir.
No. Set of 5 cardinality is 1.
So I did not get this.
Why? The question is why, right? 5
Mm,
set can be considered as an empty box. Am I right? It's an empty
yes,
box.
yes,
Then
sir.
what is actually set of 5?
Empty set.
5 can 5 is considered a empty box. Then what is set of 5? It can
Empty
be
box.
considered like this. There is a box inside this, there is an empty box. Am I right?
Yes, sir.
Now, what would be the cardinality if you see from the outmost box? There is a box inside, right? Of course, definitely a box inside. Though it is empty, but there is a box inside. That's why cardinality of 5 set is equal to 1. Did you get it?
Yes,
স্যার
sir.
বিষয়টা আরেকবার একটু বোঝান মানে এই থ্রি কেমনে হলো বুঝি নাই স্যার
I don't get you. What happened?
স্যার এই যে থ্রি আমরা লিখলাম থ্রিটা কি করে আসলো আমি বুঝলাম না
How many elements inside universal set?
থ্রি
That's why it is 3. And that is called cardinality. Number of elements inside a set. Did you get it?
ইয়েস স্যার
Now, how many elements in 5?
0.
0. So, how many elements in set of 5? How many elements in set of 5? Same concept, box within a box. So, it is 1. Okay? Now, let's try to prove this one. If people did not mute, please kindly mute yourself. Prove that phi is a subset of you have to prove this. Prove that A is any set, then phi is a subset of A. And if A is not equal to phi is a proper subset. How can I prove that one? Tell me.
So same as before.
How can I prove that one? What would be the scheme for proving this?
All X.
By the way, how can we define logically the empty set? Then how can we logically define the empty set? What would be the definition of empty set in logic? All x such that x does not belongs to phi. Am I right?
Yes.
That is the logical definition of empty set. Acha. Then, if this is the logical definition of empty set, how can I define this? Prove that A is any set, then phi is a subset of A, and if A is not equal to phi is a proper subset of A. How can I prove that?
So first we write the expression, logical expression for the first expression, like phi is not phi is a subset of
At
A.
first, wait. If just like this, if A is not subset of B, then how can I define logically this one? How can I define this one? A is
All
not a
X,
subset. Huh?
all X,
All X then?
X is a element. X is an element of A,
Huh?
but and X is not an element of B.
All it is for all X. Is the quantifier correct? If there is only if there is only one element, then what happens? Let's assume this. 1, 2, 3. B is 2, 3, 4, 5, 6. Only one element is present in A, another, and this element does not present in B. Still, A is not subset of B. Am I right? Am I right or not?
Yes, sir.
So why you used all quantifier? It should be sum x. Am I right? Sum
Oh,
x,
yes, sir.
x belongs to A. By the way, it is good answer. X belongs to A,
Yes, sir. And X belongs to A, and I have to put it anywhere.
x belongs to A,
And
and
X
and
and
x
X does not
not
belong
belongs
to
to B.
B. Yes,
B.
sir. Yes, sir.
Right. Very good. Then, so if consider we have proof by negation. Proof by negation. So we are considering phi is not subset of A. Assume phi is not a subset of A. Assume. Okay.
Yes, sir. Yes, sir.
Then what happened? By definition of this, sum x belongs to phi, and x not belongs to A.
A.
Am
Yes,
I
sir.
right?
Yes, sir.
But by definition of phi, we know that by
A.
definition of phi, we know that all x not belongs to phi. Am I right?
Yes, sir.
So these two cannot simultaneously happen. So definitely it is wrong. So phi is a subset of A. Did you get it?
Yes, sir.
Now let's take the second part. If A not equal to phi, then what happened? That is sum x.
Sir, paper 2
Let's consider this is part number 1. This is part 1. This is part 2. Part 1 is done. Part 2. If A is not equal to phi, there are some x not belongs to phi, x not belongs to phi, and x belongs to
A.
A, which is nothing but definition of proper set, proper subset. So what happened at the end? If A equal to not equal to phi, phi is a QE. Done. Did you get it? So this is the definition.
Very tricky, sir.
Huh?
These proving things are very tricky.
It is a little bit tricky. You have to think.
Yes.
True.
Sir, here phi is not a null set, right?
Phi
Phi
is a
is
null
just,
set. Oh, definitely phi is a null set.
but sir, how can it be possible that if phi is a null set
Hmm.
and phi
Phi
if
is a,
phi is a subset, null set, how can it
yes.
be a proper subset of A?
Proper subset because there are some x which does not belongs to phi, but some there's a one extra element in A. That's why it's a proper subset. We prove it by definition. If A
Uh,
is not equal to phi, there are some x where x not belongs to phi, but x belongs to A.
স্যার বাট
That's why it's a,
পাইয়ে তো কোনো এক্সই নাই, এটাই তো আমার মানে
so
কোনো
এই জন্যই তো phi কোনো x নাই দেখি তো এটা লিখলাম। It is true. First part is true. X not belongs to phi.
স্যার তাহলে কি আমরা মানে এটা বলতে পারি যে ইফ এর এলিমেন্ট হলো গিয়ে 1 2 3 আর
Mhm.
ফাই তো নাল সেট, তাহলে মানে যে কোনো সেট এরকম এ বি যেটারই বলি না কেন
Right. এই
সবগুলো,
যে A is any set. A is any set.
হ্যাঁ তো এই এনি সেট
A is any set.
যেগুলোর মধ্যে এলিমেন্ট আছে সেইটা
শুধু element থাকা লাগবে না, এলিমেন্ট না থাকলেও চলবে। A is any set. A is any set. I'm going to clear this here. I'm telling the theory. A is any set. That's the your question answer is already given.
হ্যাঁ স্যার আমি ওইটাই বলছিলাম যে মানে যে কোনো মানে যে কোনো সেটের সাবসেটই মানে প্রপার সাবসেটই একটা ফাই মানে নাল সেট হতে পারে।
হ্যাঁ আসেন আগে এই কোশ্চেনটা আসেন, সেটাই তো বললাম ফার্স্ট পার্ট তো তাই বলতেছে। A is any set, then phi is a subset. Okay. Now the question is, can it be proper subset? Listen. If A is not equal to phi, that means if A is not empty, then phi is a proper subset of A for any set. For any set. Am I right?
Okay,
On
sir,
the
এটাই
other hand,
ছিল।
if A equal to phi, then what happens? Phi is a subset of phi. So that is the thing. Did you get
Phi
it?
is a subset of A or phi is a subset of phi.
Phi is also a subset of phi.
Oh, so A is equal to phi. Yeah.
A is equal to phi. When A is
Yeah.
equal to phi, phi is a subset of phi. So in that case only, it is actually subset. Other cases, it is actually proper subset. But we know that whenever something is proper subset, we can also write as a subset. In the very beginning of the class, we have proved that. Okay, guys?
Yes, sir.
Okay, now let's go to next theorem. Prove that if A is any set, A is a subset of A. How can I prove this one? How can I prove this one?
For all x equal
For all A, for all X,
element of A
element of X is an element of A.
implies that
When
A is what? All X. X belongs to A. Am I right?
yes, sir.
So if this is the case, all X belongs to A implies X belongs to A. Because this one is true, then this one must be true. This one must be true. So this one becomes tautology. Easy.
Yes.
Am I right?
Yes.
You can write this. So what is this? This is nothing but definition of
Yes, sir.
done.
কিন্তু স্যার এটা এটা আমরা ইকুয়াল প্রুফ করলাম না।
না আমি যেখানে ইকুয়ালে যাই নাই, আমি ইকুয়ালে যাই নাই। I got to অ্যাকচুয়ালি ইকুয়াল প্রুফের জন্য আমরা মনে আছে কি করি, দুই ওয়েতেই প্রুফ করি। আপনি একটু যদি কনসেন্ট্রেট করেন, কোশ্চেন করার আগে যদি একটু ভেবে নেন, তাহলে মনে হয় অনেক কোশ্চেনই হবে না। কোথায় গেল প্রুফটা? এই যে প্রুফটা দুই সাইডে প্রুফ করি, A implies B and B implies A. Then we prove bidirection. You have to tell me this thing, right? So you
Yes,
did
sir.
not prove a bidirection. That's why it's a subset. Did you get it?
Yes, sir.
Yes, sir.
Any more question? Now let's go to another concept. Then we'll stop here. Power set denoted by PA. What is power set? Set of all subset is called power set. So let's assume my A is 1, 2, 3. So how many subsets are possible? If my A is 1, 2, 3, how many subsets are possible?
3.
3.
1, 2, 3, 4.
What are those?
So 4, how about null set? One null set? No, 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 no.
Tell
3.
me.
1,
What would be the first one? 1, then
2, only 2,
only 2,
only 3,
only 3,
then 1, 2, 3,
1, 2, 3,
1,
1,
2,
1, 2,
2,
uh,
3,
2, 3,
1,
1,
3,
1, 3,
1, 3, and
no more. So
and
there will be the
and null set.
null set is always subset of any set.
yes, sir.
We know that from there. So how many there? 1, 2, 3, 4, 5, 6, 7, 8. So there
Yes,
are 8. So if you make a set of all this subset, then you get power set. 1, 2, 3, So what is the cardinality of power set in this case?
8, 7.
8. 5 is there.
1, 2,
8.
3, 4, 5, 6, 7.
Okay, guys. So let's stop here today. We are already much advanced today. Today the people presence is less. We'll start in the next class from this point. Okay. Still then, just wait a minute so that I can take your attendance. You people come here today.
Yes, sir.
So let's take the attendance first. So we'll stop here today. Next class will start from here.
Sir, I have a question.
Yes, please.
Sir, like when are we gonna have a test? Like because these for the test we're gonna have a huge syllabus if we keep on adding it and stuff. It will be very tough to
Yeah,
practice.
so don't worry. When I'm going to take the quiz,
Yes, sir.
by the way, in the midterm, you have to prepare with all the topics we have
Yes, sir.
covered.
Yes, sir.
So there is nothing major things if I take quiz on all the topics. I don't think so. Am I right?
No, sir. Like, it's gonna be tough for us because,
Yes,
like,
sir.
uh, if we keep preparing little by little and prepare for exams on little topics, then we can like
Learn
focus
more, sir.
But
on those.
but actually after Eid, when the quiz would happen, that time you get very little amount time to further prepare for the meet. So isn't it better to prepare everything before meet? Isn't it better?
Sir, there is
So how
also
many quizzes are you gonna take? That's like
I
the
have
main
no
problem.
problem. I have no problem if I reduce your syllabus. I don't have any problem. But you people are going to suffer in the midterm for that, not
So
me.
what if we do it like this? Like it's just a suggestion. Like we divide the syllabus up till May in two parts. We give half of them for the quiz,
Okay, no
and then
problem. No problem. Okay, no
after the
problem.
quiz we
Okay,
just have
okay.
to
Let,
prepare for
let
the
me
other
let me
half.
finish. Let
Yes,
me finish. Let me finish. So take quiz up to logic and set theory, and and midterm is everything like logic, set theory, and function. Is that clear to
sir,
you?
how many quiz are you going to take?
I'm going to take 2 quizzes. Usually those are equivalent to 8 quizzes, but in this semester, instead of taking 8 quizzes at the beginning of the class, I merge all the 4 quizzes first in a big quiz, and all the last 4 quizzes merge into second big quiz. So that is the strategy.
Sir, like if you can take like 4 quizzes all together and like
No, it is not possible because 4 quizzes I'm going to take quizzes online, and so online quizzes is already very hassle.
uh,
Though I have developed my system, but still I cannot take 4 quizzes. I'm extremely sorry about that. It
And
is not possible.
I want to share something.
Yes, and actually, the our coordinator, Dr. Habib bin Muzaffar, he has actually advised us to take only 2 quizzes. So sorry, I'm sorry about that. There will be no chance of we are doing bad in this quiz so that we can recover. No, you
Yes.
have to be very prepared before exam, and you have to be careful in performing good in the exam. So this semester there is no option. So that is the bad thing of actual online classes. Okay. Anything
Sir,
else?
sir, yes,
Yes.
sir. So last day I had a quiz where, sir, the net kept on loading. The 20 minutes quiz. It was a 20-minute quiz, but I got my question paper 15 minutes later. Like I only had 5 minutes to
So
reply to the question.
so your
Sir,
faculty member take it online.
yes, sir.
So which tool he has used?
Sir, he has used this classrooms tool. Uh, Google something. I don't remember.
Google Forms, sir. Google
Yeah,
Forms.
Google Form set. Yeah,
Google Forms. I don't think in my system this kind of problem would happen. Don't problem.
yes, sir, because it was a very terrible thing. Like we had only
So
I had
just
maximum of 5 minutes.
just actually participate in the quiz, in the demo quiz on the Saturday. Then you people getting more favor. Don't worry. Okay. We have still more time.
Okay.
Any more question?
So this Saturday, sir.
This Saturday, yes.
Okay.
Okay. Take care. Bye.
okay.
Assalamu alaikum, sir.
Sir, attendance ম্যাম স্যার
And now.
Assalamu alaikum, sir.